Assalamualaikum. Let's discuss on the tutorial number 2, question number 1. So when you want to answer question number 1, you need to draw a schematic diagram. Always draw the schematic diagram. So this is how the schematic diagram looks like. Okay. Make sure you label all the streams involved. Okay. So you need to label your feed stream, distillate stream, and bottom stream. In the questions, you are given the mole percent of benzene and the mole percent of toluene. So, convert it into mole fraction. So, the mole fraction of your distillate for benzene is 0.9. The mole fraction of your benzene at the bottom is 0.1. And at the same time, the mole fraction of your feed for benzene is 0.5. So A is benzene, represented by benzene because benzene is lighter compared to the toluene. Okay, so we are going to represent benzene as a symbol of A. Take note that when you talk about mole fraction does not have unit at the back. So these are the common mistake made by majority of the student. They put unit when they write mole fraction, so which is wrong. Alright, in this question you are required to calculate the flow rates of your distillate and the flow rates of the bottom. So distillate represented by the symbol D, bottom represented by the symbol B. You are given the feed flow rate as 100 kg mole per hour. So to solve for your distillate and the bottom, so you have two unknowns, therefore you need two equations. So one equation comes from the overall mass balance, and you need another equation which comes from the component A mass balance. So altogether you're going to have two equations to solve for two unknowns. Okay, so you have to remember that if you have two unknowns, you need at least two equations to solve for the unknowns. Same thing, if you have three unknowns, you need to have at least three equations to solve for the unknowns. Okay, so you solve using two equations simultaneously, and you get your answer for your distillate and bottom product. Okay, since you have gathered all information in your schematic diagram, now it's time for you to calculate the theoretical number of trays needed. So you need to read the question carefully and then determine what is given to you. In the questions, you are given the reflux ratio as 4.52. Since the reflux ratio is given to you, therefore you are able to develop or determine your enriching operating line, and the symbol given for your enriching operating line is EOL. Okay. Remember, each time you are given the reflux ratio value, you have to relate this value with the EOL, because in the EOL equation you have reflux value to be inserted into the equation to solve for the rest of the questions. Okay, so since your R is 4.52, you just substitute the value of R in the EOL equation. What we need is only the y-intercept or the y-intercept for your EOL. So in this case, the y-intercept is given by these values. Alright, when you have the value of the y-intercept of EOL, you just estimate, or from your graph, you just label as xd over r plus 1, which is equal to 0.16. So let's say this is the value. So you're going to start drawing your EOL starting from this position, because remember, for EOL you have this kind of variables. Okay, so To proceed on what you have, to draw the EOL, you just draw straight line from here, from XD to the y-intercept. Yeah, y-intercept here. Okay, so that is how you draw your EOL. Okay, this is how you draw the enriching operating line. Okay, so make sure you draw a straight line starting from the vertical value of XDA and then intercept with the y-intercept of the enriching operating line. Okay, so draw a straight line only. Okay, so make sure in your graph you label your graph where you have to label your mole fraction of your bottom product, mole fraction of your feed, and mole fraction of your distillates. So these are all about the A components or your lighter components, which are considered as the one that has a lower boiling point and vaporized first. Okay. Alright, next, when you read the question, you are also given the condition of the feed in the question. So it's mentioned here the feed is heating up to the saturated vapor. So this is considered as a condition of the feed. When you're given the condition of the feed, you have to settle your QOL. What is QOL? QOL is the Q operating line. Okay, so you are given it is your feed is saturated vapor. So the value of Q is equal to 0. Okay, for saturated vapor, and the line is a horizontal line. Okay, so this is how the Q operating looks like when the value is equal to 0. Okay, so you're going to draw your Q operating line starting from the feed, the value of the mole fraction of the feed. Okay, so the mole fraction of the feed here, which is 0.5. So therefore, starting from here, you draw the straight line or horizontal line for Q equal to 0. Now you can draw the stripping operating line. Okay, so you begin from this XBA, draw vertical line from XBA to the 45-degree line, and then draw a straight line meet the two operating line that you have before. Okay, so altogether you're going to have 3 operating lines. So now, once you have your stripping operating line, then you can draw the stages. Okay, so remember, to draw the stages, you need at least 2 operating lines so that you can have the third operating line you're going to draw where both original or earlier operating line meets. So you're going to draw your operating line which is intercept at the 2 earlier operating lines. So starting from your distillate, you're going to draw the stages. So starting from here, you just draw the stages. Okay, so the boundaries is this one. Okay, so this is where you have your EOL, and then you have to go through here. Okay, all right, because when you draw the stages, it must be outside of the EOL and SOL. Okay, so you draw. Okay, so you just stop when it reach one stage above the mole fraction of your bottom. Okay, so this is how you're going to calculate. So you have to number the stages that you have produced: 1, 2, 3, 4, 5, 6, 7. Okay, and 8. Alright, so why we have 7 and 8? Because this is the boundary. Okay, the boundary. So based on this graph, your stages should be around 6 point something, not more than 7, because the steps for 7 is not finished yet. So you have the portion. So this is 6. Now everything here is 7. So your answer is 6 point something here. Okay, so how to measure this one? So let's look at the total length of steps number 7. So you just use your ruler and measure the total length of steps number 7. Okay, and then use your ruler to measure the length of this part only. Okay, so this part, the length of this part, divide by the length of overall part. Okay, you're going to get the decimal number. Alright, so based on my graph, let's say my answer is about 6.7. I get 6.7 stages from my graph. Therefore, the theoretical number of stages should be 6.7 minus 1, because we need to minus the reboiler to get the theoretical number of stages. So now the answer of theoretical number of stages is 5.7. In the questions, when you answer the questions, you need to write 6.7 minus 1 equal to 5.7. So this is to show that this is the value of the stage that you get from your graph. And then you know that you need to minus 1 because this involves the reboiler. Therefore, the theoretical number of stages is the value that you get after you minus 1. Okay? Alright.